All right, so let's take a look at this thing. So, does this question look familiar? Okay, hopefully. It should look really familiar. It looks really similar to your test, but now we're starting to throw in a little function notation. So, when we see this function notation here, f of x and g of x, same thing. You can replace that first thing with any letter you want. Typically speaking, when you see a function, you're going to see f, g, or h. You can put other ones there, but it's typically going to start being like v of t is the velocity at time whatever. Ones you're probably not going to see very often is I of x, because I means something else in math, and most of us feel awkward using it as a function. So typically f, g, h are going to be your common ones. Plus, if you're starting to graph more than 3 functions, you're not doing it by hand. So we just use computers to do that at that point. So when I plug these in, remember, these are x values. They go in the x position. So this one is 1/2 to the negative second power. What do I do with the negative power? It says, hey, you're on the wrong side of the fraction. Since that is a power rule and it goes to the top and the bottom, the whole fraction flips. So this is really 2 squared. What's 2 squared? 4. It's okay, me too. So, same thing, 1/2 to the negative first is really 2 to the first, which is, Malachi's with me, 1/2 to the 0 power is,
why does it become a 2?
Because, yep. Notice how every time we are going forward, we are multiplying by 1/2. Everything is always 1/2 the size of the thing that came before it. What's half of 1? 1/2. Because I'm just multiplying 1 times 1/2 is 1. Then here I multiply by 1/2. I get 1/4. Then 1/8. Notice, do I have to plug it into the function? No, I can just notice the rule. Hey, I can just be multiplying by this value. And it makes it a little faster once we get any value. So I want you to go ahead, take a moment, and try this one, but try to not plug the numbers in. Try to get one value, and then just use the rule. What am I going to multiply by as I go down? 2. So find one value and then double it going forward. And if you need to go backwards, do the opposite. Divide by 2 instead of multiplying. I'll give you a couple minutes to do that, or 60 seconds. All right, what is the easiest number for me to get a value for? If you have to choose one, 0 is the easiest. Because what is 2 to the 0 power? Thank you. It's 1 every single time. Then going forward, what is 1 times 2? 2, 4, 8. Going backwards, I multiply by 1/2. What's half of 1? 1/2, 1/4. Notice how these are kind of going in opposite directions of growth. That is because this first one is what is called exponential decay. This is exponential growth. How are we feeling about the graph so far? Just we're on the table portion. Now we need to actually put this thing into a graph. So, notice, did I give you any graph paper? No, so we got to sketch one. Of course it is. Please excuse the technical difficulties. What would it be? Trying to do a quick lesson. I'm trying to be done talking in like under 10 minutes. Hey, there we go. We're back online. So whenever we're sketching a graph, remember we want to do this way, remember. Y-axis, x-axis, negative y, negative x. Now, little detail. Do we hopefully have a general idea of what an exponential function is going to look like? Am I going to use any of this dead space down here? No, why not? Can't have negative numbers. There's a what? We'll call that wall where the values can't go past. What is that rule? What do we call the thing that says that an exponential function cannot go below a certain value? Yes, I'll get one here in a bit. What is that vocab term? Flip through your notes, see what do we call that thing that a value cannot go below? No, the range is related. Yeah, the asymptote. Our nice weird word. So what I'm going to do when I'm drawing this thing is I can just move that down, can't I? Because this thing's just going to start on the x-axis and go up. And then, if you don't have nice grids, throw some dots in. You can, fancy word here, partition out your graph however you would like. So something I like to do when I'm drawing my graphs like this is, you'll notice here, I do little lines, 1, 2, 3, 4, and my fifth line I make bigger. That way when I'm going and I'm graphing things, I can just immediately jump to 5 and go, okay, 5, 6, 7, 8. You don't need to do that. I'm doing it so I can draw it bigger for you. Because it'll be fine. So the reason I'm doing it here is because we're going to have this asymptote, right? That's going to be about there. That says no values can be down here. I won't use that bottom half of my graph. So I'm doing it this way so that I can maybe draw this thing bigger and you can see it a little better from the back of the room. If you already did and you're like, mine is perfectly, everything is a square and it's the right length, that's fine. Doesn't matter. So that first function, our exponential decay, we go up. I'm going to zoom out so we can see it. My first point that I'm going to graph is negative 2, 4. I feel like my iPad has just decided you wanted this to be a short lesson, but I said no. Seriously, my goal was under 10 minutes today. You'll find out. My goal is to stop talking as quickly as I can get away with today. So we come over here, negative 2, up 4. Then we go to that next point, negative 1, 2. Over 0, up 1. 1, 1/2. 2, 1/4. And eventually 3, 1/8. Now, is there anything stopping you from going and adding more points if you want to? If it would help you draw your graph better, do it. But you don't have to. You can just look at this and go, hey, this thing's going to look like this. I'm going to ride that asymptote and curve up. Make sure your graph looks like this, that you are not dipping below that asymptote. As soon as you dip below the asymptote there, the asymptote's a wall. You cannot cross it. If you cross it, your graph is incorrect. It is wrong. How we feeling? Maybe a little bit better than test? So then, this other function, negative 2, 1/4. Negative 1, 1/2. 0, 1. 1, 2. 2, 4. And 3, 8. So I'm just pulling those values down from the table and I'm putting them into a point notation so that I can graph it. So negative 2, 1/4, negative 1, 1/2, 1 or 0, 1, 1, 2, 2, 4, and 3, 8. Notice how I use that to my advantage, making that line really big. I can just jump, and now I'm just going 1, 2, 3. That's 8. And same thing, remember, we're going to come along asymptote, and then shoot up. And we should see that pattern. Now, we want to talk about, or I'm going to introduce something called a axis of symmetry here. So if I were to come in here, I'm going to make this line a little bigger, really denote that it's something separate. Do you notice how with this thing, everything is mirrored across this axis of symmetry? That, oh my God, stop going to the eraser. Here, I'm on the axis of symmetry. I have a point from either function. When I go out one, see how everything lines up. What would I know about this point then? Well, if 2 or 3 out here gives me a value of 8, what should be the value here for -3 on this function? Yeah, it better be here, this bonus point, -3, 8. Does that happen when I plug that into the function f of x? Is f of -3 8? What do we think? Negative power flips. That is, in fact, 8. So hopefully, graphing may be feeling a little bit better. If not, if you're still looking at this and you're going, what the heck just happened? That is a sign you need to come into office hours. If you are planning on retaking, you need to come talk to me. Preferably today. I'll be here during lunch. So far, 4 people have talked to me and said, hey, I'm planning on retaking. I think more than 4 people need to retake. So make sure if you are in that boat, you need to come see me today during lunch. Just stop by. It doesn't even have to be a long conversation. You can come have that longer conversation next week and say, hey, I want to sit down and look at my test corrections. Most people so far, it's going really fast. In fact, one person showed me probably the most beautiful test corrections I've ever seen in my life. So good, I'm probably going to ask, hey, can I copy this, take your name on it, and I'm going to just stick it on my wall as a poster. This is what test correction should look like. Be working on that. Now, let's add in a little teaser. I'm changing the plan because the iPad decided to interrupt the day, so I'm going to interrupt it now. Question for you, and I want you to give me a good answer. Ask, are f of x and g of x inverse functions? Justify. I'll give you a few minutes to get me an answer on this. And I want this. This is your own personal work. I don't want to know what your friend group can come up with. If you have questions, you are welcome to ask, but I'll put up the official answer here in just a minute. All right. How do I know if these two things are inverses? They go into each other. But is that the definition of an inverse function that we covered last class?
Inverse function undoes what the original function did.
Inverse function undoes what the original function did? No. So how do I know if they're inverses?
I'm doing it.
Well, remember last class I said an inverse function, I use a different color here, reflects across a certain line. Do those functions reflect across that blue line?
The line of symmetry.
But the line of symmetry is not what they need to reflect across. If this was an inverse function, your inverse would look like this. So graphically we can say not inverses, but how do I mathematically show it? What did we do yesterday to show that two functions were inverses? No. But I just was talking about 60 seconds ago. Remember yesterday we took these functions and we plugged one into the other. The fancy word for this is called function composition. So I take one function and I plug it into the other. In this case, I'm plugging in g as the x value of my f. So here, if I take this thing and I plug in 1/2 to the 2 to the x, does that feel like that's about to give you x out? Not at all. Because let's think about, okay, can I break this down? What's 1/2 squared? What's 1/2 squared?
Yeah, 1/4.
Yeah, 1/2 squared is 1/4. So, I'm going to zoom in so we can really see this. 1/4 to the x is that x. No. These are not inverses. These are cool, they're related, but they aren't inverses. One is not undoing the other. So here, the answer to this, not inverse functions. And there's your justification. Little bit, not a ton. Yep. All right. So what we are going to do now, that is it from me. I want you to log on to Delta Math. And you have an assignment on there to work on to practice some of these skills. What? So please get out your notebooks and work on the 5.4 assignment.